My name is Paul Grønsund from Telenor, working in the group unit in research. So I will try to tell a bit around what we think about 5G and also a bit around what we are doing on virtualization and try to tell a bit around why that is so important. Then I want to also dive a bit into some of the challenges that we have had and also things that we have been working on a lot the last years. First, I just want to say this is a statement, and you can agree or you cannot agree. I think most of you guys will agree in this room, but it's not obvious to all. So what I'm saying is that network virtualization is a prerequisite for 5G. And it depends on who you ask. If someone from the radio department is being confronted with this, maybe they don't agree. So, but for other areas, I think it's pretty obvious. But anyway, let me try to prove it. So if you look at 5G, what is the vision we have with 5G? And the vision is, it's a lot about empowering the vertical industries, delivering new type of services, digitizing those industries, and helping them innovate and automate and improve efficiency and so forth. So you have a lot of them, like factories of the future, where you see remote control, time-critical control of factories, the energy sector, you have the e-health sector, also with robotics and also remote monitoring. So you see that some of these services are really critical. The communication has to be up. Same for automotive, with automated driving. An obvious one, share my view. Maybe a quite interesting one where you, from the car, you show to the rest of the world what you're seeing, or to someone else. And also bird's eye view, that you're in the car and you get a view of what's happening in the surroundings. That also requires a lot from the network. And also media and entertainment is another vertical, and there are more. So we are working with all of these industries, or most of them. And what's interesting to see is that most of the industries are really eager. They want to see what can 5G deliver and how can it help us. And there are so many use cases to handle, and we need to see where is the opportunities. So we are working a lot on this. And also when we look into the different vertical industries, what are their requirements on the network? And if you map it to some of the 5G KPIs as you see up here, you can see that the different use cases, in this case in the automotive industry, they have quite different requirements. And if you look at another one, the e-health, you see, wow, it's actually very different. And if we are to build a 5G network serving all of this, we need to have some sort of mechanism to isolate them and give them specific requirements or SLAs, basically. And what is the answer to that? I think we have talked about it. I think I'm probably repeating some of the things that has been said earlier, but it's about network slicing. We want to have this one physical network, and you see here the radio or the fixed side to the left, and then you have edge networks or edge clouds, the core clouds, and also public clouds. So that's the physical infrastructure, and we start adding the logical networks on top. And then it's about using NFV and SDN, basically. But you also need some way of orchestrating this. So you can add more, and you see that in all of the different slices, we have different allocation of resources, and we can also associate the KPIs with them, like latency, availability, and so forth. So virtualization is indeed important, right? But we can also look at the KPIs of 5G. And I like this illustration because it has some aspects which is not always covered. So in the inner spider, you see the 4G and what are the KPIs and values for 4G. And in the outer circle, you see 5G, what's expected. So obviously this one is clear. We have latency. How do we achieve low latency? And that's because of speed of light. We need to go closer to the customers. That's where edge is coming in. It's not always needed because, I mean, our core data centers are not that far from the customers, so the latency is not that bad. But there might be cases where you really need low latency. And this one as well, reliability, requirement on 5 nines, that's pretty tough to achieve, and we all know how expensive that is. But the fact, when you have virtualization and you can set up the different services and slices with different reliability, gives us a powerful tool, because then we can configure high availability for one slice, and for the other it might be less, depending on what they can pay for it, basically. And this is an interesting one, because this is, I'm not sure if I saw that with 4G, but it says 90 days with 4G. And that is really tough to achieve, 90 days. That's not easy. And if we then move to 90 minutes, that's wow. Then we need to have a programmable network. And without NFV, SDN, virtualization, that is not achievable, in my view. And energy efficiency, 10% of current consumption. That's also a tough one. And we can do a lot in the devices, reduce the power consumption in the devices and also in the radio networks. But if you move things into cloud and you get the flexibility of shuffling around the resources, maybe powering down something, optimal replacement and so forth, that's needed. And for the rest, not directly related. But still, I believe that having virtualization as an engine of, and with flexibility is important for those as well. So well, I think that is kind of proving it. I believe, you might disagree, but anyway, network virtualization brings the programmability and also flexibility. But of course, we need some orchestration. So putting everything together, I will be short because this has been presented previous in the session. I mean, we have this network with edge, radio, fixed access. We have data center also in the central site and public cloud. So then we put up the applications, mobile core, IMS. These are all applications that we are virtualizing now. And we have them running in VNFs. Next step is probably to do the radio access network, actually taking the processing part sitting at the site of the base stations and moving it into the cloud. And you know that the latency requirement is pretty hard, and also the capacity requirement. So edge makes a lot of sense. Then, and public cloud is also something we use for certain applications, but it depends a lot on where is that cloud and what type of applications, what is the cost model, what do we want to use. But certainly we need to have this capability. Then scaling, extremely important. I mean, we have talked about this for many, many years, but as you see, if we are to put on all these different vertical industries, have logical networks for each of them, and they will also be scaling independently, we need to be able to automate those things. And equally important is scaling down, actually. Because if we don't do that, then there will be a lot of wasted resources across those slices. And if you only had the mobile network and the general usage, it's a bit more static, but when we introduce these verticals, there will be a different pattern of usage in each of them. All right, we can move things and we can replicate things. And putting the mobile core into the edge is also something that is useful if you want to do local breakout or do bandwidth saving. And then for the rest, I mean, there will be applications from those verticals into those setups. So right, then explaining, I will be quick because I think this is also obvious from the previous presentations. Slicing onto this. We put up the VNFs, configure the connectivity with this SDN, and here we have an automotive slice. We can also have a e-health slice, so you see that how, I'm not sure, yeah, so you can see how the latency is different from the different slices. So that's why we need to put things in the edge. But you might also have something like an enterprise service with video streaming or conferencing. And there you see that the latency is not that hard, but the bandwidth might be hard. So anyway, some ways of putting it up. So we believe that virtualization is a must for slicing. Okay, then some more words about orchestration and automation. And I think at least the previous presentation from Ericsson is a bit overlapping with what I will say, but I will try to put something more to it from our perspective in operation. So if you look at this architecture, you might have a bit different picture. That's not the most important thing here. But in general, we have like the different domains, physical network functions, transport, and this one growing So this is growing really fast, and we want that to happen, because we don't want to have all these things in parallel. We want to get everything into here, basically, and that quick. And then we have the NFV orchestrator and also the end-to-end orchestrator, looking a lot into how these are some overlapping, and they are working together as well. So, I mean, one important thing for us when it comes to automation is lifecycle management. It might sound a bit simple, but it is very important. Healing is a very important one, but it needs to be done right. So we had one case, for instance, where we wanted to do healing of a VNF. So it went down, and we started to heal it, basically spinning it up again. But then we had healing going on in OpenStack, and we also had healing going on in the VNF manager at the same time. So it was spinning, spinning, spinning. Those type of things, how do you set the policies in the network, is something that you need to get experience with and need to have a careful handling of. And then you also have lifecycle management on different levels. So you need also to have policy sets between those. How do you actually do that? It's very important. And then obviously service assurance. And I've drawn it up as a thing on the right. It might also be integrated. We know that it's getting more closely integrated with the fulfillment. But it's sitting there doing, I mean, if you introduce NFV and SDN and you also have traditional performance, fault and security and log management, it's not working perfect. We need to have more correlation of the data from the different parts of the network. So, and one important thing, I'm not sure if you noticed this one, but we have some service assurance block out in the network. And I want to stress the fact that we need to do service assurance as close as possible to where the fault or issue is. And that will become even more important when we move into edge computing. We need to do it where it has to, where it is happening, and then escalate only what has to be escalated up into this end-to-end part where you can do the analytics. Of course, you can escalate things like data that you want to do analytics on, but the problem should be solved locally, if possible. Yeah, and then comes the cognition loop. So that's something we all try to achieve. So this is the big cognition loop, but also note that there are cognition loops in parts of these blocks as well. So it needs to work both in the layers, across and between the layers. That is not so easy. This is very important. Then I wanted to touch a bit on some of the things that we have been working a lot on, and one of them is security, because the cloud, the NFV setup needs to be fully secure. So we have this zoning model. That's not a new thing. But I mean, if you see it, it's like you have physical separation, physical firewalls between the zones, whether it's the secure class, the non-exposed and the exposed, where you want to put the services across those. And within them, between applications, you have virtual firewalls or micro-segmentation from SDN. So the thing is that when you try to put out the service, you need to configure security policies across a different set of firewalls. You might even have different firewalls. And when you scale it, you might need to update something. If you migrate something, you also need to update. And this is very important to be automated. And having that automated also gives you the benefit that you actually avoid more human failure. But you need to do the automation right. That's something we have been working a lot on. Second part is security or firewall as a service, and we also see this becoming much more important now when we start working with many of the vertical industries, because they also need application level security on the content level, application level, user level, and so forth. So I think that has also been discussed throughout this conference. So automation of security is a key area. And secondly, also for service assurance, also a bit related to security, because we need to monitor, we need to get visibility into the network and applications. So we do tapping, and you know, if you want to tap traffic, if you want to have a probe in there, we all know how much that can consume of traffic. It can double the amount of traffic in the fabric, and also the compute nodes, if you do it virtually. So we have been working a lot into how to make that design efficient. So if you have VM to VM communication, you tap in the virtual switch. If you have between two compute nodes, you tap in the leaf switch. And if it's north-south going to the radio network or the internet, then you tap actually, as we have done before, physical tapping, splitting in the fiber. And that gives a lot of optimization on how to do the tapping. But again, you also need to automate it. So when you put in a service and you want to tap something, it should be part of the descriptors. That's a very important thing for automation. And then also another area of monitoring is, or testing actually as well, is on putting in test agents within the network services, within the slice. So imagine if you want to put up or launch a service, you would like to test it, you would like to push traffic through it. Not go out in the field and spend many weeks, but you want to do it virtually. You want to put up the virtual probes and actually push the traffic. And that also needs to be described in the network service descriptors, how to do that, and in the VNF descriptors, so you can automate it. So please have a look at the POC number 1 from OSM, where we did this. So that's some challenges. Then I want to talk a bit about, actually we wanted to present this or demonstrate this here, but we did not manage to get that ready in time. So we are running a POC, it's on open source mono, because we believe open source mono is extremely important. We need to have a common information model, and for us it's also important to have a reference implementation of the mono stack or the NFVO and VNF manager in order to improve and drive the efficiency in onboarding VNFs and network services. So this is a very important area for us. So we are running a proof of concept together with Telefonica, where we are looking into also bringing in slicing in OSM. So we do slicing of two parts, or services, one for the mobile broadband, which is the traditional slice, and the second one for mission critical. Then we actually look into how do you differentiate those, because they are different. One thing is the quality of service, on the latency aspects, and also on the capacity, availability, how many nines do you need, assurance, and that is also a bit related to the probing part. How much of the traffic do you actually want to tap? Do you want to tap all the data plane traffic? Maybe you do for some slices, maybe in mission critical, maybe not for mobile broadband. Maybe it's enough with the control and signaling traffic in mobile broadband. And security as well. How much security do you need? And that's also related a bit to cost and complexity. So you might want to do that for some slices, but not for others. So we are looking into that, being orchestrated by OSM. And so we have the VNFs onboarded, and we spin them up in the slices and do the description of those with the capabilities as you see here. Second thing is on cross-domain, and we also believe that will be very important. So imagine, for instance, between Telenor's network and Telefonica's network and potentially others. But if you want to push some applications and you want to use a network where you're not present for a specific, say if it's a B2B type of service, a slice, you can actually leverage each other's networks using common orchestration and federation. So please stay tuned for this. We will probably come back to this place with more information on that later, and also in other events. So with that, I would like to summarize. I think, if you want to realize the vision of 5G with multiple vertical industries, and we see this happening, you need a programmable and sliceable network, and NFV and SDN is extremely important. I think I tried at least to prove that network virtualization is the answer. It has the programmability and flexibility, and finally also the need for automation and orchestration, which I think this session is all about. I tried to shed some light on what we believe there to come to the 5G vision. But it's not only that, it is important before 5G as well. But 5G is not that far away. It's actually not. So with that, I want to thank you for your attention and open for any questions you might have.
Hi, thanks for the talk. You mentioned energy efficiency and with virtualization, I mean, what you want to achieve is you would like to run any network function anywhere, right? But how do you see the need for acceleration and specific hardware functions in your network to really optimize for to be more efficient?
Yeah. I think, I mean, we do leverage a lot of acceleration technologies in the virtualization today, like SRIOV, DPDK, CPU pinning, UMA awareness, and those things. But I think you're referring to FPGAs and those type of things. Yeah.
Yeah, exactly.
Yeah. So I think, in general, we have tried to avoid that because one thing is that we are not fully confident on the openness of FPGAs, and it's a bit dangerous when you build big data centers to decide on a solution without having openness. That's one side of it, but we have been looking into it, and I think for some applications, like especially when it comes to virtualization of the radio network, if you want to do the split on layer 1 and move everything into the cloud, I fully agree with you, then that makes a lot of sense. So we are looking into that. We don't have it today, but we are looking into doing that. So I agree.
Thank you.
How do you see the coexistence of virtual infrastructure and physical infrastructure for automation in the network? Because a large portion will still be physical network function.
Yeah, so I think I tried to mention that when doing this, we are trying to move pretty fast so that we don't have that period for so many years. So that's one of the ambitions we have and what we are doing, but absolutely there needs to be an integration with the physical network functions for some time. And the automation you can do is, you can do automation within the part that is virtualized, but when there is a physical network function, it's a bit limited. You can do some automation by talking with EMS and configuration-wise, but when it comes to scaling and migration and those type of things, it is limited indeed. And then you also have SDN. If you extend the SDN out into the physical network functions, you might do some more stuff there as well. For instance, automation of security. You want to have a DDoS attack and you want to reroute traffic, and you have some of those capabilities, but it is limited. Okay.
I think we've run out of time for questions. If you have any more questions for our speakers, catch them in the hallways and ask them in person. So thank you, Paul.
Thank you.